Good afternoon, everyone. In this video, we are going to talk about how to calculate the theoretical and percent yield of a compound. So let's start. So how to calculate the theoretical yield and percent yield of a compound. So we have here the problem. 30 gram of C3H8 burns in air to produce 70 gram of CO2. Calculate the theoretical and percent yield of CO2. So here I already write the chemical equation, so we just need to balance it. So as you can see, na our chemical equation is not already balanced yet, so we're going to balance it first. So we have here a C3H8, which stands for propane, and it's burning air, so it's going to react with oxygen gas, and it's going to produce carbon dioxide, and the other product is water. So the reason being it's a combustion reaction is you always get CO2 and water as a product. Now we got to balance, and whenever you want to balance a combustion reactions, you want to balance the number of carbon atoms. First, we have 3 carbons on the left side, so we're going to put 3 in front of CO2. So here. Next, we're going to balance the oxygen atoms. So we have 8 on the left, 2 on the right. So as we all know that 4 times 2 is 8. So we're going to put a 4 here. So and then finally, we need to balance the oxygen atoms. So you have 6 oxygen atoms, 3 times 2 equals 6. 6 oxygen atoms. And then 3 CO2 molecules, 3 CO2 molecules, 4 on the right from H2O, that's 10. Yes, that's 10. Then 10 divided by 2 is 5. So we need to put a 5 in front of O2. So now the reaction is already balanced. Now let's make a list of what we know. So we have 30 grams of propane. Now it's burned in air. So we can assume that we have an excess amount of a oxygen. So whenever you have two reactants, you need to identify what's the limiting reactant and what's the excess reactant. So you always want to use the limiting reactant to calculate your theoretical and percent yield. So never the excess reactant. So now the equation for percent yield, it is the actual yield divided by the theoretical yield times 100%. So you need to know the difference between the actual and theoretical yield. So the theoretical yield is what you can calculate. It is the maximum amount of product that you can get. So if your reaction is 100% efficient, you know the amount that you can get is the theoretical yield. So the actual amount that you can get in reaction, that's your actual yield. So the actual yield is usually given to you in a problem, unless they want you to solve for it. And the theoretical yield usually is the grams of product. So you see how we want to find the percent yield of CO2. That means that we need to use the actual yield of a CO2. That means we need to use the actual yield of CO2 as in the theoretical yield. So they gave us the actual yield of CO2. So 70 grams of carbon dioxide was produced. Yes, 70 grams of carbon dioxide was produced. That's how much we actually got in the experiment. So now we know the actual yield. So what we don't know is the theoretical yield, the most that we can get in the experiment. So let's calculate the theoretical yield. The maximum amount of a CO2 that is possible to get. So we're going to start with 30 grams of C3H8. So let's start with 30 grams of C3H8. So the first step is to convert to moles using molar ratio. So the molar mass of C3H8, which we get from the periodic table, is about 44 grams per mole. So you know carbon has an atomic weight of 12. So 12 times 3 is 36. Then hydrogen is about 1 and there is 8 of them. So 8 plus 36 is what you can get is 44. Now, you want to do this in such as way that the grams of C3H8 is they can cancel. So the next things you want to do is you want to change the substance you want. Yes, you want to change the substance. So you want to convert from moles of C3H8 to moles of CO to moles of CO2. So whenever you want to change from one substance to another substance, you need to use the molar ratio. And the molar ratio, it is 1 to 3. So for every 1 mole of C3H8 that burns in the reaction, so 3 moles of CO2 are produced. And since we have moles of C3H8 on the top left, yes, we need to put that on the bottom right so that they can cancel. And therefore, the moles of CO2 will go on the top and then simply add the numbers. So there is a 1 in front of C3H8, so we're gonna put that in here. And there is a 3 in front of CO2, so we put that there as well. Yes. So most of C3H8, so they can cancel now. So the last step is to convert from moles back to grams. So whenever you convert from grams to moles or moles to grams, you need to use the molar mass in the periodic table, which is the same as the atomic mass. So carbon has an atomic mass 12, oxygen is 16, and there is 2 of them, so that's 32. So plus 12, that's 44. Now, because we have most of CO2 on the top left, we need to put most of CO2 on the bottom right. So you want those units to cancel. So therefore, grams of CO2 has to go on top. And we said the molar mass of CO2 is 44. So that means that there's 44 grams of CO2 per 1 mole. And now we can do the calculation. So the number on the top you multiply and you divide it by the numbers on the bottom. So 30 divide 44 times 3 times 44. So let's do the calculation. 30 divide 44 times 3 times 44. So this gives us a theoretical yield of 90 grams. So what this means is that if all of the 30 grams of C3H8, all of that reacts, so the most we can get, the maximum amount of CO2 that can be produced in this reaction is 90 grams of CO2. So that's what the theoretical yield means. That the maximum amount of that you can get. Well, in this reaction, we only got 70. So now that we have the theoretical yield, we can find the percent yield. So the percent yield is going to be 70 divided by 90. It is always the smaller number divided by larger number times 100%. And so let's do the calculation. 70 divided by 90 is equals to, so it is equals to 77.7 or 77.8%. Here is the result. So that's the percent yield of this reaction. So that's how you find it. So that's all right now. Thank you and God bless.